this video I'm going to look at the Leaving Cert Applied Maths question, or 2012 question 2a. So we have rain falling with a speed of 25 meters per second at an angle of 20 degrees to the horizontal. So that's the horizontal. The rain is falling at an angle of 20 degrees to it at a speed of 25 meters per second. A car is travelling along a horizontal road into the rain. The windscreen of the car makes an angle of 32 degrees with the vertical, and the car is travelling at 20 meters per second. So let's start off by saying, well, this is our positive x direction and this is our negative x direction. And it doesn't matter what way you do that as long as you assign it the correct way around. So what's the velocity of the rain? Well, if we split this into a x and y component, our x component or our I component would be 25 sine 20i. Sorry, that's the wrong way around. That arrow should be that way. Minus 25 cos 20j. And that's a minus because we're going down, and usually we say up is positive and down is negative. So that's the velocity of the rain in I and j form. What's the velocity of the car in I and j form? Well, it's going to be minus 20i plus 0j. So there's different approaches to this. But first of all, if we're trying to get the angle that the rain appears to strike the windscreen, what we're looking for is the angle of the rain relative to the car. So if we get the velocity of the rain relative to the car, we can find this angle and then we can work from there with the windshield. So the velocity of the rain relative to the car would be VR minus VC, which is 25 sine 20i minus 25 cos 20j minus 20i plus 0j. Work that out and you'll get an answer of 28.55i minus 23.49j. Now that's the velocity of the rain relative to the car. Now, as I said, there's different approaches you could do to this, but let's just assume that the car doesn't have that windshield at an angle. The car is just a block. Well, the rain is hitting it, as far as the car can see, from the car's point of view, the rain is hitting it with a velocity of 28.55 in the I direction, minus 23.49 in the j direction. So the rain is hitting the car at that angle. So we could find this angle, we could find what it is by getting the tan inverse of the 28.55 all over 23.49. And what that's going to give us is that's going to give us this angle here, the angle that it's striking the car at, assuming the car is just a rectangular block. Type that into our calculators and we get an angle of 50.55 degrees. So that's the angle that the rain strikes the car from the car's point of view. So it's the angle that what way did the word in the question? The angle at which the rain appears to strike the car. But what we haven't included here is we haven't included the fact that this isn't a rectangular block. This is actually a windshield here. So the car actually looks something like this. So if we want to get the total angle that the rain appears to strike the car windshield, we would have to include the tilt of the windshield. So it would not just be theta, which we just figured out. We'd have to add this angle here. Let's call it alpha. And we can see that from our picture that alpha is 32 degrees. So if we want to get the total angle, it would be 50.55 degrees plus 32 degrees, which gives us an answer of 82.55 degrees. And that's your answer. Now, with this, there's different ways obviously you can approach it. But even if you're a little bit stuck with the question, you're a little bit stuck with what exactly are they asking you, what angle, make sure you write down the velocity of the rain and the velocity of the car in I and J form. Make sure you figure out V or C, because all of those things will actually get you most of the marks in the question.